Okay, here's a question. Actually, originally an exam question, this one. Okay, but we can answer it using a two-way table. Even though the question doesn't tell us to, it's kind of set up in our solution. So we've got our facilities with a gym and a sauna. So underline the important information as we go through. So they visit the Help Club together on Tuesday evenings. There's no further mention of Heidi. She must have come up in part B. We've only got part A of the question here. So I think we're just interested in Andrew, and we've got the probability he does the gym, probability he uses the sauna, and the probability he uses both. Okay, so it looks like our two-way table here we ought to have the gym, okay, and therefore not the gym. So to say not the gym, we put a dash on it, so G dash means that G doesn't happen. And then S, meaning sauna, could happen. And if S doesn't happen, then S dashed means the probability that he doesn't use the sauna. Now, unlike the last example where we had frequencies, now we've got probabilities. So I can fill in probability he uses both is 0.25. The probability that he uses the sauna overall is 0.55. The probability he uses the gym overall is 0.70. So the total probability that he uses the gym must be this plus this unknown probability here. But if I do 0.70 minus 0.25, that tells me this is going to be 0.45. Okay, and similarly these add up to 0.55, so this must be 0.30. But the one final thing I need is the total. The previous example we were told the total number of students, but I don't need anyone to tell me the total probability. The total probability of all the outcomes put together must be 1. That's just a fact about probability. So I can say if the probability is that of him using the sauna is 0.55, and the probability of S dash that he doesn't use the sauna is 0.45 because they add up to 1. And similarly, the probability of him using the gym or not the gym is 0.70 plus this one. They must add up to 1, so this must be 0.30. And when I look at this one here, I discover that he actually can't use both the sauna and the gym. Okay, now is that a surprise? He uses either the gym or the sauna or both, but no other facilities. So this suggests that he always does use, he wouldn't go to the leisure centre if he wasn't going to use one of them. So maybe that's not a surprise, but anyhow, doesn't matter. Our normal procedure for working out the table has gone fine. So the probability he does not use the gym is just a matter of writing down the answers. The probability he doesn't use the gym, the overall probability of G dashed is 0.30. All my working that I need to show is in the table, so I'm allowed to just write down the answers. The probability he uses the gym but not the sauna, so this is gym, this is not the sauna, so it's this one here, 0.45. And finally, the probability he uses either the gym or the sauna but not both. So probability of G or S is not what I want. That would be the probability of using the gym or the sauna or both. But the probability I need here is just the probability he uses either the gym and not the sauna. Okay, or the probability of not the gym but the sauna. And because these are totally separate outcomes, these are actually exclusive events, you can't do both of these at once, I can just take out the relevant cells, which are this one, and add them together. So I get 0.45 plus 0.30 is 0.75, and that's my answer. So underline all answers clearly, and we've done that question.